I'm Kevin Zhang. I'm from University of Connecticut, and Dr. Leslie Frem is my advisor. Today I'm going to talk about the post-heat treatment on the electron beam melting in Ti-6Al-4V vanadium and its potential relationship to the surface oxide formation. So, electron beam melting, or EBM, is an additive manufacturing technique using electron beam to melt and fuse the metal powder to print out the sample we want. So, Ti-6Al-4V vanadium is the most popular titanium alloy widely being applied, and it has very high strength-to-weight ratio and excellent corrosion resistance. For the EBM-built Ti-6Al-4V vanadium, its unique corrosion behavior from the traditional ROUGHT sample, which means it needs more studies. So today we are going to show some of the heat treatments here, and which obtains various different microstructure. So here is an interesting study from CHEN, etc. They perform an in situ electrochemical atomic force microscope here, and within these little cells. And you can see that the alpha phase actually corrodes faster than the beta phase, and the galvanic effect are observed near this interface. So what can this indicate on the overall performance? So let's see on this microstructure. So for the EBM sample, before the heat treatment, it has this basket weave pattern microstructure and the acicular grains. The grain size are very fine. Well, for the ROUGHT sample, the grains are equiax, and the primary alpha phase mixture with this alpha beta laminar pattern. And so after 850 Celsius for 2 hours soaking time, followed by furnace cool, the EBM sample still have this kind of basket weave pattern, but changing its orientation from the previous triangle-like pattern to this square-like pattern. And also the grain size is becoming coarser. Well, the ROUGHT sample only shows that the grain size is becoming coarser, not so much difference else. And for the 1050 Celsius followed by furnace cool, both of them have this laminar microstructure, except the EBM ones are much coarser than the ROUGHT ones. So for the 850 Celsius followed by water quench, the EBM sample doesn't show much contrast under the SEM. This can indicate that the plate-like beta phase form. And also you can see lots of these globular grains within the beta plate. This can indicate that the incomplete transition from the beta phase to the alpha phase. Well, for the ROUGHT sample, the grains are becoming less uniform, and the shape kind of being this rounded, not very pattern-like the shape, and however the grain size doesn't change much. Well, for the 1050 Celsius followed by water quench, the alpha phase near the EBM sample surface are observed. This is formed during the air exposure during the water quench process. Some of the needle-like grains are observed. Well, not very significant, but the predominantly grains are this kind of globular grains. So, and well, for the ROUGHT sample, the martensitic needle-like grains are the predominant ones. That is a very typical microstructure after the beta quench. So, to summary, the EBM samples are much different from the traditional ROUGHT sample, and heat treatment really can manipulate different microstructure that can be potentially useful for the oxide film formation mechanism study. Thank you for your attention.